Hi everyone. So welcome back. So we're going to do 1.3 here, which is compound interest, and I'm going to call this part two. Remember, there's three parts of compound interest here in unit one. As a brief reminder, compound interest is when it's same as simple interest, except we calculate that interest on previously accumulated interest, right? So if you remember, here's an example here with simple interest. It was $500 every single year. Whereas in compound interest, it was 500, 525, 551, and so on and so forth, right? So that's what that is. So we are now looking at this thing here. So this is on page 20. This is part two. This is on page 20. Oops. So I'm going to start out here with this one. Now you have the solution here down below, but I do want to start out with this because at this point, you know how to calculate compound interest. It's just this sucks to do, right? Manually writing that out, that sucks. There's math. There's faster ways to do it. So that's what we're going to be doing. So I'm going to do the learn about math example here. So here's what we know. So Yvonne earned $4,300 in overtime in a carpentry job. She invested that money into a 10-year bond that will earn 3.8%, and it's compounded annually. She decided to invest in a CSB instead of keeping the money in the savings account because the CSB, which is that Canadian savings bond, will earn more interest. What is the future value of Yvonne's investment after 10 years? So that's the question we have here. Now, if you're looking here, when I read through this, I only picked apart the important bits, right? What's the amount? That's the principal. What's the term, the length of the loan? What's the percentage? And how is it compounded? And how frequently? So that's all you really need. And then what am I trying to find, right? So that's how we read these questions. It's a skill you'll get better at. So starting out here, here's what I know. I'm going to start with putting this stuff here. The principal, right, which we refer to as P, was $4,300. The T, which is the term, how long the loan is 10 years. The interest rate, which is I, was 3.8%. Now, I need to turn that into a decimal figure, right? So 0.038 is a decimal of 3.8%. And it is annually compounded. So, how am I going to do this? Well, what we have here is we have a formula that we are going to use. Now, we kind of did like, so the solutions here, like, and at this point, I want you to actually look at the textbook, look at the left side of the screen. How did this person figure this out? They calculated just how we did up here on the right side of the screen. They did it year by year by year by year by year, right? Except they just used this formula here. We figured out the interest and just manually added it to our principal. They're doing this formula. Well, where'd they get that formula? Remember section 1.1. Look at the key summaries. This is one of those formulas here. You can see it's this one right here. So it's there. Now I want to talk about what's happening with this. So in year one, they just did that formula, right? They plugged it in, boom, one plus the interest rate plus the term. Well, it's calculated 1 year, it's compounded once. So we're going to do it for just 1 year. And they got $4,463. So after year two, they did the exact same thing we did up here, right? They took the new amount, they did the same investment, they times it by that interest rate, and so on and so forth. They times it by 1 plus 0.038, 1 plus 0.038, and so on and so forth. As you can see here, here's year one. It's times by this number. We get this new figure. So year two, they times it by that same figure. They get the new year three amount. They times it by that figure. They get the year four amount. And it can go up and up and up and up and up and up until you reach year 10 to get the answer. So we've already done that. I'm not going to make you guys repeat that. But what I do want to do is instead show the formula for this. There's a formula for this. Which is this right here. So I'm going to take this information and I'm going to bring this in. So I'm going to box this, right? You want to make it stand out in your notes. You highlight this, yada, yada. Here's our formula. So when do I use this? Before I do anything else, cool, we know the formula. When do I use it? When do I use this formula? When I have when I have to find the future value of a compound investment. Now, this can be used for both an investment where I gain money, or it can be used for a loan where I borrow money. It is the exact same thing, right? It's a lump of money that's being invested, that's compounded over a period of time. I want to know how much that's going to be at the end of it. So it's important to know how to get to like, well, I want to know what it is at year 3. Really want to make a note here. Really want to make a note here. Look at what they did. I wanted to know what it was year 3. Just how it's 1.0 times 38 times 1.038 times 1.038. They just did that 3 times instead. So it's the same thing here. So what I could do is I could formula this in. Now, don't write this down. Do not write down what I'm about to do. It's going to give you more work. What I could do is A is equal to, so I'm going to write always start with your blank formula, 1 plus I all to the power of n. I'm going to draw a little n there. Actually, let me make this a little bit bigger first. I'm going to make you bigger. Aha! There we go. So I have this. I'm doing this little power of n here. Now, what this little power is, if you don't remember this thing here, if let's say, for example, I give you 2 to the power of 4. What this is saying is you're taking 2 and you're timesing it by itself 4 times. So it's 2 times 2 times 2 times 2, right? So you get is 4, 8, 16 is the answer here. Let's say I were to give you 3 to the power of 3. Now this is the exact same thing. On a computer, this is often how we denote it. There's that little symbol here. This is the same thing as 3 to the power of 3. For you guys, you can just write what I've just written there. 3 with a little 3, right? For me, I cannot. So this is the same thing here as 3 times 3 times 3, which is 27. So that's what that is. As you can see, what they did here was instead of writing this out 3 times, they just did it to the power of 3. So that's important to know there. So again, this thing here is the exact same as A equals P, and it's 1 plus I to the power of n. That is how eventually in this course, I'm going to start writing stuff. It just makes it easier. As you can see, my notes aren't very clear when I have to use my mouse. So just be aware, this is the same thing. All right. So with that out of the way, if I want to remember, so go back to this example, right? $4,300, 10 years, 3.8% compounded annually. Well, I'm trying to figure out A, right? I want to know what the end value is, what the investment is, what the principal plus the interest is. That's what A is. Now, the principal was $4,300. And then in brackets, so that's $4,300 times 1 plus I. What's I? 3.8. Nah, did it wrong. Put it as a decimal. Then it's to the power of 10, because it's 10 years. Now I could, right, to the power of 10. So I'm just going to quickly summarize this. So that this is 4,300 times 1.038, right? Because all I did was I combined these numbers to the power of 10. Now I could just do this 10 times. There's 3, there's 4, there's 5. And so I could just do that. That gets a little much, right? So I'm going to do this instead. So at this point, you can write this down, pause the video, get that down. 3, 2, 1. So now I want to calculate that. Now on your calculator, there'll be a couple ways to represent that. So again, if I'm looking at this thing here, this 3 to the power of 3, there's a couple buttons on here that you can do that with. If I'm just trying to square something like 5 squared, 5 times 5 is 25. But once you get to certain numbers, you have to tell your calculator very specifically what it is. So this is going to depend on your calculator. Look really closely for it. So let's say, for example, I want to do this 2 to the power of 4. I don't have a 2 to the power of 4 button. I have a 2 to the power of 3 button right here, but I don't have a 2 to the power of 4 button. So what I'm going to do is I'm just going to write my number. In this case, I'm using my 2 to the power of 4, so I'm going to put 2. So now I need to look for something where it gives me the option to pick. Now, here is an option to pick. For me, it is e to the power of x. Your calculator might be different. I need you to explore your calculator here. If you really can't figure it out, email me a picture of it and I will tell you what it is. It's usually going to be in one of these upper rows though here. And you're usually going to see this e to the power of x thing here. So I'm actually literally going to put a screenshot of that. Oh, go away. In here. So that's what it should look like. So I would do now, if I press this button, oh, well, no, that's 2ln. I don't know what that is. I want to get the little red part. So 2, oh, this is red, second function. This is the second function here. So I need to press that to access that. So again, I'll show it again. I did 2. I want to access the red part here. I need to press my second function, my red button. On one of the calculators, if you were in a math class with me earlier, turn on my video. This calculator here, if you're looking, it's really hard to see, but like you can see there's some like orange stuff there. I would use that orange button on the top left, the second function. So, long story short, oh, that's not right. Wait, what? Where's the? I goofed up on you guys with you guys. Oh, my bad. Sorry, guys. Again, everyone makes mistakes. Yeah, it's this one. It's y to the power of x. My bad, guys. I apologize. So 2 to the power of 4. That's that y with an x thing there. There's my calculator. I goofed it up. Every calculator is a little different. So I can see I did that. If I wanted to do 10 to the power of 8, 10 to the power of 8. There you go. So I'm going to put this in my calculator. 4,300. Now you can put times if you want, or you can just put brackets, right? Order of operations. But 1.038 to the power of 10. Your calculator will do the order of operations for you if you put it in correctly and you set it up correctly. Now, if I do that, $6,243.69. Then there's some other stuff here, but that matches what you see right here, right? So we've done it correctly. So if I do that, it's $6,000, $243. Now, 69.9, I can't have that, right? So you can either have 69 cents or $6,243.70. Either one of those would generally be fine. Different institutions round it differently. Usually it works against your favor, right? A credit card is going to round it up for you. A savings account is going to round it down for you. So either one of those would be fine. So this is our final answer here, but I'm not done, right? The question asked, what was the future value? Write that down. The future value after 10 years is $6,243.69. Okay. Okay, so at it simple enough. Hey, awesome, we did it. Now is when I really want to clue into though that compounding period. The compounding period. Now, what is a compounding period? Well, it's in your book, thankfully. We've talked about this before. I'm not going to do a full reintroduction, but a compounding period here is the amount of time, the time over which interest is determined. And again, you can see stuff like there's annual, there's semi-annual, there's quarterly, which is every 3 months, there's monthly, weekly, there's daily, there's so on and so forth, right? Again, if you refer back up to unit 1.1 here, blah, 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 blah. Here you go. We've talked about this before. We talked about the difference between semi and buy, all these different ones here. Do refer to that if you don't remember. But now what happens, everything we've done, every single example we've done, it's compounded annually. What if it's a car loan? What if it's a mortgage? What if it's a credit card? Those don't compound yearly. You want to maximize your money. Now, one thing I want to note is, remember, going up here, every single time this compounded, it went up, right? $25, 26 and $26 and a quarter, $27 and a half, right? This one here went up $29, and so on and so forth, right? So the more you compound, sure, we'll put a loan. Sure. The more I compound a loan, the more interest is accrued, right? The more interest there is. Now, think about a credit card. If I'm Visa or I'm MasterCard, what is my goal? If I lend you $1,000, would I want to do credit cards? Do they want more or less compounding periods? Do they want that to compound yearly, monthly, quarterly? Or do they want that to compound daily or weekly or monthly? Remember, what's the goal of a credit card company? It's to make the money, right? So they want to compound it more because the more I compound, the more money I make. Your credit card compounds daily. Believe it or not, if you're like, I pay my credit card at the end of every month, you're paying some interest still, baby. So again, compounds daily. Daily. So, and you as a consumer, this will always work against you, okay? If you lend out money, it's going to usually compound less. If you borrow money, it's going to usually compound more. So, just an important figure here. So now what we're going to do is, well, what happens if it's more than once a year? What happened if I compound a figure more than once a year? So I'm going to look here now at example 2. Blah, 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 blah. Here we go. So on example 2, on page, what is this, 22? Page 22. So Matt has invested a $23,000 inheritance, right? So the principal is $23,000 inheritance into an account that earns interest rate is 13.6%, which is the same thing as 0.136. Now the interest rate is fixed for 10 years. So the interest rate is fixed for 10 years. So what that means is the term of the loan is 10 years. Now, even though it says, well, he can use this in 5 or 10 years, he has the option for up to 10 years. So the term is 10 in this case. And it's compounded semi-annually. What does semi mean again? Refer to 1.1. Semi-annually is 2 times per. So semi-monthly is 2 times per month. Semi-yearly is 2 times per year. So 2 times per year is really the key thing you need to know there. Okay, so I have my principal, I have my interest, I have my term, and I have my compounded period. I have everything I need for my previous formula up above. So Matt plans to use his money for a down payment on a house in 5 to 10 years. So we want to know, well, how much is it going to be worth in 5 years? What's it going to be worth in 10? So question A is asking you to do this equation twice, right? So, I'm finding out the future value of a loan that's compounded interest. Sorry, I'm finding the future value of a compounded interest loan. Ding, 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 ding. Here's your formula. So A, blah, 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 blah. So A is equal to P, 1 plus I to the power of N, right? So we're going to start out here with the 5-year. My principal was $23,000. I, 1 plus I, 0.136 to the power of 5. Now, you could at this point save yourself a step. A lot of the times from this point forward, I'm going to skip this middle step. It's 1.01. So 1.136. So a lot of times from this point onwards, I'm going to skip this step, okay? So just be aware of that. I'm doing that step automatically. I do still want you to have this top one. Always write the blank formula. Always, 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 always. I will deduct marks from your work if you do not. I know that makes me seem like a dick. You will learn it better, I promise. All right. So simply put, all I got to now do is plug the numbers in, right? $23,000. 1.136 to the power of 5, right? Here's my power button. Here's my power button. Here's my power button. A equals $43,000, $513.04 and 4 cents. Let me just double check that. I messed up, guys. We made a mistake, and I did this intentionally. What did I forget from this stuff up here? What of these 4 things did I forget? I have the P, I have the I have the term, right? It's either 10 or 5. I forgot to deal with the compounded semi-annually. This interest rate, right? I'm crossing this out. And I'm going to write an explanation. I did not compound semi-annually. So it is at this point, I want to refer you back to a previously done example in the textbook. You don't have to go back to it in your book if you don't want. I'll find it here for us. Give me a second. Here we go. So this is on page page 9 here. If on Sunny's example, now her stuff was compounded semi-annually, just as we are. And as you can see, now this was simple interest, but the same principle still applies. It was calculated every 6 months instead of every year. We just calculated it every year. And I also want to refer you back to this thing here. Again, reading your textbook is careful. I said T. There is no T in this formula. There is N, which is the number of compounding periods. So I missed something here. N is equal to 2. So let's do it properly this time. 5 years, correct. So 5 years done correct. So first thing I need to know here is, so I'm going to write a formula now, and it's going to be 1 plus I, and I'm going to add something here. To the power of N. Specifically to the power of T times N. Now I'm going to write this formula out a little bit nicer here. So A is equal to P, 1 plus I. Sorry, this is supposed to be divided by N. So there's a reason I left a space here. Divided by N. Then this is to the power of T times N. Now, what's happening with this I? It's being divided by N. What is N? What is N? What is N? The interest rate is being divided by the number of compounding periods. So first thing I'm going to do though is I'm going to box this. This is an alteration of this formula up above. I don't quite like this one. I feel like this one makes more sense because this actually shows you all the hidden steps. There are hidden steps up here. If you guys look over here on the left side of the screen, they did some hidden steps. So instead of this 13.6% interest rate, well, it's done twice a year. I need to divide that then by how many times it's compounded in a year, which is twice. If this was monthly, this would be a 12. Hunk of junk mouse. If this was monthly, this would be a 12. If this was yearly, this would be if this was weekly, this would be a 52. If this was daily, this would be a 365. I would divide this figure by whatever is down here, okay? So that's an invisible step. So instead, what I like doing is I like including this in here. The other thing, so that one, that still with the I, but two, the compound in periods, it does not compound, it compounds twice in a year, but it's a 5-year loan. So it's 5 years times 2 compounded periods, it's 10. So n's actually 10 in this case. So in this case here, if I include everything in here, so A is equal to my principal, which is $23,000 times 1 plus I divided by n. My interest rate is 13.60136 divided by how many compounding periods in a year? 2. All to the power of what's my T? What's my loan term in years? 5 years. And then how many times is it compounded in a year? 2, which is 10. So this is what it actually is. I know this isn't what's in your textbook, but I promise you'll be better ahead if you do this. So just like before, I'm going to simplify this before I start calculating. $2,300. So 1 plus, how do I do a fraction? If you have the calculator that I gave you last time, it's this little button here, this A and B button. I always keep your stuff in fractions, guys. If you can, keep it in a fraction. If you're always the kind of person who's like, so if you're always the kind of person who's like 0.136 divided by 2. Okay, so this is 0.168, and then add that to 1. Right now that works. Later, that's going to bite you in the ass. So keep your stuff in fractions if you can, right? So 1 plus fraction. If you don't have that button, you can do brackets instead. 0.136 divided by 2, right? Notice that this is the same thing. This is the same thing as, so this is the exact same thing as what I'm writing here on the right. Look at the calculator on my screen. Same thing. The brackets there, I'll do the same thing as the fraction button. It's just some extra work. All right. So first off, I'm simplifying this. 1.068. So this is now 1.068, right? Which makes sense. 13.6 divided by 2 is 6.8. 1.36 divided by 2 is 0.068. All right. To the power of 5 times 2 is 10. All right. A little bit easier to work with in our calculator now. $23,000 bracket 1.068 bracket to the power of, not squared, to the power of 10. My total investment after 5 years will be $44,000, $405.86. So after 5 years, this is an important figure. It's not the answer. I'm going to underline it. I'm going to box it. I'm going to do something to it. Make your stuff stand out. You're going to get lost otherwise. We've already spent 10 minutes on this question. You need to make your important answer stand out. This is not the final answer. This is a answer. So that's 5 years. Now let's do the 10-year, right? So A is equal to P, 1 plus I over N to the power of T times N, right? Again, just doing this to get us more familiar with it. So A is equal to $23,000 times 1 plus I, which was 0.136. It's compounded twice in a year, right? So divided by 2. Again, you're noticing I'm keeping it as a fraction. Important. All to the power of 2 or 5 times 2. Right? Which same thing. $23,000 times 1.068, right? That's what the same thing as before. All to the power of I messed up. It's not a 5-year loan. It's a 10-year loan, right? Again, always refresh yourself. So it's to the power of 20. So $23,000, 1.068. Oh, to the power of 20. And I can see a 10-year loan, in this case, leave it in there for an extra 5 years, $85,000, $733.96. So, question A again asked us, what is the future value after 5 years? Check. What is the future value after 10 years? Check. I have my answers. Here are the future values after 5 and 10 years, respectively. So if we look at the principal and the future values here after 5 and 10 years, what do we notice? What's happening? Right? So for question B, kind of a thought-provoking one here. There's not necessarily a wrong answer. So comparing the values, so my principal, so I started with $23,000. After 5 years, it was $44,405, right? Or I'm just going to put 44,500, right? Keep it simple here. Because this is just thinking like broader terms in this case. And then after 10 years, it was about $86,000, right? About 86. I'm just keeping it simple. This isn't the exact amount, and that's fine, because this is a thought-provoking question. It's not a math question necessarily. Well, after 5 years, how much larger is this? How much larger is this? It's less than double. So it almost doubled. Actually, I'm going to write that. It almost doubled, but not quite. Not quite. It almost doubled. But what about after 10 years? Damn. 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 How much larger is that? Oh, that's almost 4 times as large. So what we can kind of see here. So again, what do you notice? After 5 years, it didn't even double. After 10 years, it is almost 4 times as large. Basically speaking here, guys, generally speaking, again, first thing I even talked about, the more you compound a loan, the more interest is accrued. It compounded more, so it growed faster and larger every year, right? The more it's invested, the more it's compounded, the longer the loan, the more interest it is. Now, I want to bring this back to a car example. Now, I don't keep this a secret. I drive a Kia. Pardon my language here. I fucking hate it. I hate it. I hate it, guys. I hate it so much. Because it keeps breaking down on me. Don't buy an Optima. Burns oil. Ugh, terrible. So I've been thinking maybe I should get myself a new car. You know, I drive a lot. I need something reliable. I have a pretty decent job. You know, I have my finances generally established. I could do it. So I wanted to go look at cars. Now the market's kind of crappy right now for cars. If you haven't noticed it, things are expensive. So usually when you go into a car loan, like, hey, welcome to Kia, welcome to Toyota, welcome to Ford, welcome to blah, 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 blah. You want a car? Sure. We can give you up to A 7-year loan. Now, a couple years ago, though, let's say 10 years ago, the maximum loan was 5 years. Now, I won't show you, I'm not going to prove my answer here. You'll get the chance to do that later. But basically speaking, only 2 extra years, right? So I'm taking so the loan is out for 2 extra years. The interest doubles in those 2 years. So let's say, for example, here, I'm just picking a random number. I buy a $40,000 car for 5 years. Maybe I'm paying $4,000 in interest, right? $40,000 loan, $4,000 interest. It's costing me $44,000 at the end, right? If I do that $40,000 car for 7 years, I might pay $8,000 in interest, right? Because it's compounded more. The loan's longer, the interest accrues more. So now that same car cost me $48,000, right? So the longer you take out a loan, the more it compounds, okay? Now, question C here. If the investment had earned simple interest, would the relationship between the principal and the future values have been the same? This isn't asking me to solve for simple interest. It asks me a theoretical question. What if we had solved for interest? Would this relationship, would this accelerating growth be the same? If the loan was simple interest, the principal, if the loan was simple interest, the principal would gain interest at the same rate every year, regardless if it's 5 or 10 years. Right? Whereas, as we can see in a compound loan, longer gained more interest. Sometimes that works for you if you're investing money. If you are borrowing money, that sucks for you, as you can see in the car example. See car example. Okay, we're almost done here. None of this is really that much like newer. I think you're all pretty good with it. One thing I do want to go to here is, here we go. There's not too much more. One thing I do want to add here is this. Come on, you hunk of junk. The rule of 72. Now, in the rule of 72, write this down. So pause the video, write it down. 3, 2, 1. So this estimates the doubling time on an investment. 72 is divided by the annual interest rate as a percentage to estimate the doubling time of a loan. So, for example, how long for a $10,000 loan to double if interest is 6%? Actually, no, we'll put 4%. More realistic with today. So if I give out $10,000 and I can be like, you gotta pay me 4% interest, I want to know how long to double. How long to double? Well, simple put, 72 is divided, right? So 72 is divided by the interest rate as a percentage. So not 0.04 in this case, but actually by 4. So 72 divided by 4 will give me 18, specifically 18 years. So in 18 years, my loan will double, right? Well, let's check that out. Let's double check, right? So I'm going to use one of my formulas for simple interest here. Here, A equals P 1 plus RT. So A equals P, so $10,000 loan, right? 1 plus 0.4, right? That's the interest rate. To the power of, I said, what did we say? 18, oh, not squared. To the power of 18 years. If I'm right, this should be close to $20,000. Hey, it's close to $20,000. It's not exactly 20,000, but it's an estimate. So yes, this works. So this is absolutely a thing. So sometimes you're going to see examples where you're going to have to do this. So you need to know that stuff. So at this point, what I want you guys to do, so your turn, I want you to complete the your turn on page 28, right? We have a rule of 72. Then I want you to complete 1.3 in your textbook, 1.3 in your workbook. And then what I'm actually going to have you guys do here is do your assignment as well. Now, I'm not sure if I'm going to do this right now for 1.3 or 1.4, but you are going to have to actually calculate a car. You're going to find a car and you're going to actually calculate that stuff. That's yours going to be your assignment. I don't know if it's this one or I don't know if it's your next one, but you will know once you see it. And before I'm finished here, again, write in your key ideas, your summary here. Important information to have. I know, oh, it's so much writing, but I promise you'll be better out ahead for it. So make sure you guys get this information in your book. And I will see you for 1.4.